Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester for BTech 7 semester students is optoelectronics and optical communication. And the topic that I discussed today is comparison of photodetectors. So we already go through all the detectors, photodiode, PIN photodiode, and Avalanche photodiode. So in this slide, we summarize all these three, photodiode and sub, and and focus on the comparison of or the performance of all these three photodetectors. Okay, okay. We start this lecture with what is the function of photodetectors, or what is the meaning of photodetection or photodetector. And we already know that this photodetector is a part of optical receiver, right? It's a very, or you say it's a main part of optical receiver. So overall, what actually optical receiver do in optical communication? Actually, optical receivers converts optical signal, of course, which is a light signal or light, to electrical signal, current or voltage. So actually, this to be, of course, because of photodetector is a part of optical receiver, so that's why we say optical receiver do that. But the main converter of optical to electrical signal is a photodetector, right? So we also say that it is a optical to electrical converter. So photodetector is the fundamental element of optical receiver, which is followed by amplifiers and signal conditioning circuitry. So apart from photodetector, which is a main part of optical receiver, we have for amplifiers and signal conditioning circuitry. All are work together to give the output. So there are actually several types of photodetectors, and we already know the three photodetectors that we discussed in previous lectures. These are photodiodes, photo multipliers, photoresistors. Before we move to compare all these photodetectors, come to what are the requirements of a photodetectors, right? What you want from photodetector to do, right? And which type of photodetector do you want, which is suitable to use in optical communication? So we start with what we want. Photodetector should be good, sensitive. Its sensitivity should be good. Means its responsivity is to be good, right? At the desired wavelength, and poor responsivity elsewhere. So you and the second thing that we want from photodetector is we want fast response time and high bandwidth, right? And the physical dimension is compatible with the size of optical fiber. Low noise, this is also be desired, because we have to maintain a particular signal to noise ratio at a certain level. And insensitive to temperature variation, this is also be desired. This is also be required. and long operating life and reasonable cost. So these are some points that should be in photo detectors, and we use photo detectors that fulfill these type of uh, favorable conditions, having good responsivity, have a wavelength selectivity, have good and have fast response time, high bandwidth, compatible with dimensions, low noise, insensitive to temperatures, and long operating life and reasonable cost. So due to the previous requirement that we discussed, so only photodiodes are used as a photodetectors in optical communication system. Actually, we have these choices: photodiodes, phototransistors, photomultipliers, and photoresistors. So in these 1, 2, 3, and 4, we use this photodiodes, right? Because photodiode fulfill these conditions. Now, photodiode, we have positive intrinsic, negative pin photodiode, but that photodiode have no internal gain. And second is avalanche photodiode, and avalanche photodiode has an internal gain of M due to its self multiplication, right? That we already discussed. M is the multiplication factor or a gain factor sometimes. Now come to the PIN photodiode. So in PIN photodiode, photons are penetrated into a semiconductor. It will be absorbed as it progresses through the material. Means the photons that have an impact on the active layer of the semiconductor, these photons are absorbed, and these photons transfer their energy to the bonded electrons, and electrons gain energy and become free. So there is a free electrons because of the absorption of photon. So there is a photocurrent, because free electrons always gives you a current, and because the current is only because of photon, that's why we say that it's a photocurrent. And this photodiodes, we use photodiodes in a reverse bias condition, because we want a current due to photons, not because of the external voltage. So we always have a reverse bias. We always give the reverse bias to this PIN photodiode. So PIN photodiode means we have to insert a intrinsic type of layer, and this is sandwiched between P and N type P and type P or N type semiconductors. And when the photons that is coming from the optical fiber, photon is a basic element of a light, having energy of h mu. H is a Planck's constant and mu is the frequency. So when these free electrons are generated, then there is a current that is flowing across this photodiode, and this particular current is flowing through the external load, and when you multiply this photon current with the load, you get the output. So and this is also equation. You can see the equation, that this equation is this is the power at a particular distance. Distance means intrinsic layer is have a certain width. So at any position you can find out the power that is so that power have have some exponential type of equation, like current equation and voltage equation. So we have a power equation, acts at any point, any distance, and Pn as actually is the maximum power. This is the maximum power, because when electrons, when the impact of photons, then there is some time required so that you get full free electrons, then you get full flash current that you have. So this particular equation gives you the idea that it's a sinusoidal type of process. So because of the absorption of the photons, then you have a photocurrent, and IP is the photocurrent, and that flowing through the external circuit. And this is also be noted that uh, that the photocurrent that you have is actually proportional to the incident light of power. This is true because the more the number of photons have impact on the active layer of this diode, then more is the electrons are free to flow, and flow of free electron is nothing but is a current. So the current that you get at the output of this photodiode is actually proportional to the input, and input is the light power, right? So this is also be true. Now come to avalanche photodiode, and that diode we already discussed in previous video lecture. APD actually has an internal gain which is obtained by having a high electric field that energizes photo-generated electrons and holes, right? So these electrons and holes ionize bound electrons in the valence band upon colliding with them. So this mechanism is known as impact ionization, right? So when the electrons and holes are free, actually electron have negative charge and hole have positive charge. So the atom get ionized, So that is and this is because of the impact of photon. So we call this phenomena as a impact ionization, right? So the newly generated electrons and hole are also accelerated because they are in high electric field, and because of high electric force they are accelerated by the high electric field, and they gain enough energy to cause further impact ionization. So when the electrons are free because of the impact of one photon, this electron have a high acceleration, high force, and because of that they knock neighbor bound electron, and because of that force the neighbor electrons are also free, and if the second electron have enough power or energy, then that creates a third electrons. So you may say that if sometimes one photon creates three electrons instead of one, and this is happen in avalanche photodiode because very high reverse biasing is to be done, and because of the high reverse biasing, very high electric field is to be generate at the depletion region or at the active region. So the when the electrons are free, they have very high acceleration and very high energy, so they are responsible to further generation of free electrons, and that is impact ionization. And so the newly generated electrons and holes are also accelerated by the high electron field, and they gain enough energy to cause further impact ionization. So this phenomena is actually called avalanche effect, and that's why the name is avalanche photodiode. Look at the structure of APD. This is the structure of APD, and you can see that one photon creates free electron, one free electron creates two creates four creates eight. So this is the multiple, the electrons are multiply if you see in the picture. So by doing high reverse biasing, this is intrinsic layer which is in the middle, and because of the absorption of one photon, that creates a free electron, and this free electron of high energy, high accelerated electrons create two more electrons, two create four creates eight, and this is the multiplication. And because of the multiplication of the electron, you get a huge amount of current. So the current is actually the amplified internally, and this is the basic concept that involved in avalanche photodiode. There are some terms that we already discussed, quantum efficiency, which is denoted by eta, and is the number of electron hole pair generated per incident absorbed photon of energy h mu, and is given by. So eta is the ratio of number of electron hole pair generated upon number of incident photon absorbed. And the electron number, if you want to know the what is the number of electron, then what you have to do, you have to divide the photon current with its charge. Then you get the number of electrons. And number of photons, total energy, total power of the light, and if you divide this by a energy or power of one photon, then you get the number of photons. So IP is the photocurrent generated by a steady state optical power, Pn incident on the photodetector. So APD has a high gain due to self-multiplying mechanisms used in high-end system, and the trade-off is the excess noise due to random nature of the self-multiplying process. So APDs need high reverse bias voltage. Sometimes it is nearly more than 40 volt, and sometimes it is nearly 100 volt. So therefore, costly and need additional circuitry. That's all. Thank you very much.